Welcome to This Explainer. Today, we're taking an exclusive under-the-hood tour of the RAG architectures. That's Retrieval Augmented Generation, that are making AI significantly smarter, more reliable, and honestly, way more autonomous by the year 2026. If you've ever wondered how exactly AI is moving past that simple prompt and response phase to actually doing deep, structured research before it even opens its digital mouth, well, you are in the right place, so let's dive right in. So, the complete RAG landscape for 2026. I know, it might look a little intimidating at first glance with all those diverging paths and interconnected nodes, but don't worry, we're going to break it down step by step. By tracking a single query, kind of like a physical object moving down an assembly line, we're going to demystify exactly how these complex systems actually work together to build a perfect answer. Our system tour itinerary today covers 5 distinct engines: hybrid RAG, graph RAG, agentic RAG, corrective RAG, and finally, multimodal RAG. First up on the tour is hybrid RAG. This is where dense meets sparse. This architecture operates a lot like casting a massive net and throwing a highly precise spear at the exact same time. It's really all about capturing the best of both worlds in search technology. To understand how it works, we just need to quickly define our terms. Traditional search, which you're definitely familiar with, relies on exact text matches, right? You search the word apple, it looks for the word apple. We call these sparse keywords, and the system uses indexes like BM25 to find them. But AI brought us dense vectors, which actually capture the deep conceptual meaning of your query. Dense vectors know that Apple might mean a smartphone, a piece of fruit, or maybe a record label, depending entirely on the context. Hybrid RAG just brings these two powerful concepts together. So, how does it actually function under the hood? As your query enters the system, it splits down both paths simultaneously. One path heads straight to the vector database to find that conceptual meaning, while the other hits the BM25 index looking for exact keywords. And here's where it gets really cool. The next step is a clever mechanism called reciprocal rank fusion. Think of this as the ultimate mediator. It mathematically merges those dense and sparse results, scores them, and hands only the absolute most relevant top K chunks to the large language model. You're getting the nuance of AI combined with the pinpoint accuracy of traditional search. Moving on to number 2, graph RAG, finding answers in relations. Now, if hybrid RAG is a superpowered search engine, graph RAG functions way more like a brilliant detective stringing red yarn across a conspiracy board. Here, the system relies heavily on a knowledge graph. In this model, answers don't just live in isolated blocks of text. Instead, they live in the very specific relationships mapped out between entities. The nodes represent entities, like a person or a company, and the edges, meaning the lines connecting them, represent relationships, like works at or located in. The whole point is that the architecture understands the world as a complex web of connections, not just a random pile of documents. Tracking our query through this particular engine, it's first processed by an entity extractor to identify the key players in your question. Once those entities are isolated, it performs a subgraph retrieval, basically pulling out the exact relevant web of connections from the massive larger graph. Finally, it generates what are called community summaries. It essentially looks at clusters of connected info and summarizes them, handing the LLM the absolute perfect relationship-rich context it needs to generate a spot-on answer. Next up, number 3, agentic RAG, executing a plan, not just a step. We're seeing a massive shift with this one because retrieval is no longer a static, one-and-done step. It's a dynamic plan managed by an autonomous dispatcher. Your query is immediately handed off to a planner agent. This agent looks at the question, builds a strategy, and then delegates tasks to highly specialized tools. It might send one piece of the puzzle to a vector search tool, another to web search, and a really data-heavy chunk to an SQL database tool. All those distinct findings travel down the assembly line to a reasoner agent, whose sole job is to synthesize all that diverse data into one single final answer. But here's the absolute kicker, and honestly, it's kind of brilliant. This architecture acts exactly like a highly caffeinated intern. If the reasoner agent looks at all that data and realizes it's still missing some crucial context, it doesn't just give up. Nope. The agent loops back around, it furiously Googles, queries SQL, searches vectors again and again, literally looping its searches until it is perfectly confident to present the final answer to the boss, which in this case is you. Architecture number 4 is corrective RAG. It's time to grade the retrieval. Think of this one as introducing a very strict teacher into our assembly line to ruthlessly grade the work before you ever even lay eyes on it. Following the query here, the retriever pulls documents normally, but before the LLM gets to see anything, an evaluator steps in. This is self-correction at its finest. If the evaluator deems the documents correct, they get a green light and go straight to the LLM. But if they're graded as incorrect or even just ambiguous, the whole system hits the brakes. It triggers a query rewriter to formulate a much better question and kicks off a web search fallback to find accurate information. It literally refuses to let bad data poison your final answer. And finally, architecture number 5, multimodal RAG, one unified index. This is the ultimate polyglot engine of 2026. It seamlessly understands multiple data formats all at once. For the longest time, RAG systems were strictly limited to text. But human knowledge isn't just text, is it? In multimodal RAG, the system processes text chunks, images, complex charts, and dense tables entirely simultaneously. All these different visual and textual inputs are fed directly into a shared multimodal embedding model, using advanced tech like CLIP or ColPoly, which then translates them all into a single common mathematical language. Because absolutely everything, whether it's a paragraph, a pie chart, or a photograph, is mathematically housed in one single unified vector index, the retrieval step pulls exactly what's needed, totally regardless of its original format. It then feeds this incredibly rich, multi-format data into a multimodal LLM. This means the AI can simultaneously see a chart and read the text surrounding it, delivering an incredibly comprehensive answer that draws on all available visual and textual evidence. So, we've covered 5 amazing engines today. We walked through hybrid, graph, agentic, corrective, and multimodal RAG. Across all these distinct, highly complex systems, the ultimate goal really boils down to 5 core upgrades. We're basically talking about upgrading the underlying filing system rather than just inflating the AI's brain. By strictly structuring exactly how the AI searches, links, plans, grades, and sees data, these architectures guarantee smarter retrieval, stronger context, better decisions, and ultimately future-ready AI that delivers trustworthy answers. And that brings us to a rather profound realization. I want to leave you to ponder this massive leap in system logic. As these AI architectures learn to autonomously plan their own research, evaluate their findings, and rigorously correct their own work before ever speaking a single word, will they soon become more trustworthy than the humans asking the questions? It is a fascinating paradigm shift, and understanding how these structures work is your front row ticket to the future of AI. Thanks so much for joining me on this explainer. Keep asking great questions, and I'll catch you next time.